Oh, sir. Good afternoon, good evening, students. Screen is visible, no? Screen visible avudamma?
Sir.
Okay. Okay. Let's எங்க ஸ்டாப் பண்ணுமோ from there I will continue. Okay. Significant rule here only. Okay. What is significant rule? Digits of number that are meaningful in terms of accuracy or precision. That is called significant rule. On net. The number of meaningful digits in a given number. That is called significant rule. Okay. To represent the result to correct number of significant figures, we round off as per the rules. There are 3 rules of determining how many significant figures are in a number. 3 rules இருக்கு. Non-zero digits are always significant. Any zeros between 2 significant digits are significant. Non-zero digits except 0. Any number means that is significant. And zeros between 2 significant digits are significant. Suppose 505 means that is significant. 0 also significant. And a final 0 or trailing zeros in the decimal portion only are significant. Units of measurement, second chapter. That's continuation. Rule number 1. Non-zero digits are always significant, we said. That is, numbers like 26.38 would have 4 significant digits and 7.94. How many digits? 3. So, significant digit is 3. Rule 2. இந்த சிசி இது ஏதோ வருது அதுவா லெட்டர் மாதிரி அது ஆமாம் அது ஏன் இப்படி கீழே வருது திரும்ப கீழே தான் வரும் மேலே வருது தெரியல ஏன்ட்டு டிஸ்பிளேலேயே வருதுங்களா அது Okay. Now rounding off. Rule 2. Any zeros between 2 significant digits are significant. Example, 406 have 3 significant figures. Is it? 406. I said any zeros between 2 significant digits. So 0 is in between 4 and 6. Therefore 406 3 significant digits. And rule 3. Final 0 or trailing 0 in the decimal portion only are significant. Example 0.00500 means 3 significant figure. And trailing 0 is a old number or non-significant. That is Final 0 means before that trailing 0 in a whole number are not significant. That is 2530. This 30 is not significant. Therefore 25. These two only significant figures. Rule 1. If the digit to be dropped is less than 5, then the preceding digit is left unchanged. Example, 8.22 is rounded off as 8.2. It's less than 5, so rounded off as just 8.2. If the digit to be dropped is more than 5, then the preceding digit is raised by 1. Example, 6.87 means is greater than 5, therefore 6.9. If the digit to be dropped is 5 followed by digit other than 0, then the preceding digit is raised by 1. Example, 7.851 is rounded off to 7.9. That is 5 is followed by other than 0 as 5.1. So it can be increased by 1 as 7.9.
Excuse me, sir.
Yes, tell me ma.
Sir, screen telling, sir.
Oh, what about other boy? உனக்கு தெரியுதாப்பா?
Yes, sir, தெரியுது sir.
ஸ்கிரீன்ல வந்து chapter 1 chapter 2 அந்த மாதிரி தான் சார் தெரியுது.
ஷேர் பண்ணனே. உனக்கு வருதாப்பா? ரவுண்டிங் ஆஃப்னு வருதா? ரவுண்டிங் ஆஃப் ரூல் 4. மதி விராட் உனக்கு தெரியுதாப்பா?
Yes, sir, எனக்கு தெரியுது sir.
ரவுண்டிங் ஆஃப் ரூல் 4 தெரியுதா?
Yes, sir, தெரியுது sir.
ஓகே, அப்போ சிவகாவியா உங்களுக்கு எதனா பிரச்சனையா தெரியலையே?
சரிங்க சார்.
ஏன்னா நீங்கள் வெளியே போயிட்டோன்னா உள்ளே வந்து பாருங்க ஒன்று அப்படி வேணா.
எஸ் சார்.
பேக் போயிட்டு வந்து பாருங்க. வெளியே போவேன்னா பேக் போயிட்டு மறுபடியும் வந்து பாருங்க. சரியா? ஏன்னா இங்கே வந்தவுடனே இன்ஃபார்ம் பண்ணுங்க. சரிங்களா?
ஓகே சார்.
எப்படி சார் வெயிட் பண்ணலாமா கண்டினியூ பண்ணலாமா சார்?
கண்டினியூ பண்ணுங்க சார்.
ஓகே. Rounding off. Rule 4. If the digit to be dropped is 5 or 5 followed by 0, then preceding digit is left unchanged. If it is even. Example, 5.250. Rounding off to 5.2. That is 5 or 5 followed by 0. This 5 is followed by 0 means then no increasing number. Just keep as 5.2. Previously we discussed that if greater than 5 means you can round it off as extra one number, add one number. Less than 5, no need to add. If it is 5, then சொல்லுப்பா. உனக்கு ஸ்க்ரீன் ஷேர் ஆகலையா? ஓகே, நான் ஸ்க்ரீன் ஸ்டாப் பண்ணிட்டு மறுபடியும் ஷேர் பண்ணுறேன். ஷேர் ஆகுதா?
I don't have.
Tell me ma, what is your problem?
Sir, still the screen not shares.
Okay, நான் ஸ்டாப் பண்ணிட்டு மறுபடியும் ஷேர் பண்ணுறேன். I'll share
Okay,
once
sir.
again. Just you wait.
Okay, sir.
வீடியோ இருக்கே சார், இங்கே தான் இதில் வருது. இந்த இமேஜ் அதான்.
Sir, share ஆகுது.
இப்போ ஷேர் ஆகுதா? அவங்களுக்கு ஆகுதான்.
Okay, sir.
இப்போ பாருங்க. இதுக்குள்ளவங்களா? பாருங்க வருதா? இது உங்கள் ஸ்டூடெண்ட்ஸ் கிட்ட ஒன்று கேட்கட்டுங்களா? ஸ்டூடெண்ட்ஸ் ஒரு ரைட் கார்னர்லேயும் லெஃப்ட் கார்னர்லேயும் என்னுடைய வீடியோ வருதுங்களா? இமேஜ் எதுனா? எஸ், என்னுடைய வீடியோ தெரியுதாம்மா இல்லை இல்லையா? தெரியலையா? தெரியுதா? ஓகே, அப்போ இங்கே சாருக்கு தான் தெரியும் சார். அவங்களுக்கு தெரியுதுன்றாங்களே சார். போயிடலாங்களா? இப்போ நான் என்னுடைய மொபைலில் செக் பண்ணி பார்த்துட்றேன். அதாவது நான் உட்காந்துட்டு இருக்கிறது பேக்கில் நீட்ன்றது அந்த ஸ்டிக்கர் அதெல்லாம் தெரியுது இல்லையா ஸ்டூடெண்ட்ஸ்?
அதெல்லாம் தெரியும்.
தெரியுது. ஓகே. ஸோ அவங்களுக்கு தெரியுதான் சார்? பட் ஆனால் யூடியூப்பில் வரல இல்லை சார்? யூடியூப்பில் வரல. ம் ஓகே. ஓகே, ஆக்சுவலாக இது வந்து யூடியூப் லைவ் ஷோவில் போகுது, அதான் செக் பண்ணுறாரு. சரியாம்மா? நான் போகலாம் இல்லைங்களா? ஓகே சார். ஸோ அப்போ நான் கார்னர்லேயே போட்டுறேன். Rule 4. If the digit to be dropped is 5 or followed by 5 followed by 0, no, then there is no increase, just 5.250 as 5.2 itself. Rule 5. If 5 or 5 followed by zeros, then the preceding digit is raised by 1. Example 3.750. This number is odd number on the. If 3.7, 7 odd number. If it is odd number, then it can be raised by 1. Okay. And errors in measurement. Uncertainty in measurement is called an error. Random error, systematic error, gross error are the three possible errors. First one, systematic errors. These are reproducible inaccuracies that are consistently in the same direction. That is called systematic errors. These occur often due to problems that persist throughout the experiment. Systematic errors can be classified as follows. Different types, that is instrumental errors. When an instrument is not calibrated properly at the time of manufacture, instrumental errors may arise. That is, a calibration is very, very important for all the instrument. For example, screw gauge, vernier caliper and all calibrated every year. Okay, if it is not calibrated, error will occur. That type of error is instrumental error. If a measurement is made with a meter scale whose end is worn out. Meter scale, suppose we are using meter scale here. Wait. Suppose there is a meter scale. Suppose the end is not proper like this, and if you are using this one, you will get some error. That is instrumental error. Errors in measurement, imperfections in experimental technique or procedure. These errors arise due to the limitation in the experimental arrangement. As an example, while performing experiments with a calorimeter, proper insulation should be takes place. That proper precaution should be takes place. Otherwise, error will occur. That is imperfection in experimental technique. Personal error. These are due to individuals performing the experiment due to incorrect initial setting. Initial setup should be made. That is not done. Personal error will occur. Errors due to external cause. There is a change in the climatic condition, temperature, humidity, pressure, that one. That is the errors due to external causes. Least count error. Least count is the smallest value that can be measured by the measuring instrument, and the error due to this measurement is least count error. Instrument's resolution ends in the case of this error. Least count error can be reduced by using high precision instrument. For example, what is the least count of screw gauge? Yesterday only we discussed. Least count of screw gauge is? Come on. Come on, tell me.
Least count of screw gauge வந்து 0.01 millimeter.
Yes, 0.01 millimeter. இது screw gauge. Yes, gene போட்டுக்கிறேன். Vernier caliper
0.1 millimeter.
millimeter. So, இது centimeter சொன்னீங்க
Screw
millimeter
gauge
இது.
is used to measure the
Thin
width of
wire.
wire.
Ah,
Vernier caliper used to measure the width of ball.
very good. Okay, least count of vernier caliper. Repeat it once again. 0.
Least count of vernier caliper 0.01
centimeter.
0.1 millimeter.
0.1 millimeter. Okay. Least count is in terms of millimeter, 0.1 millimeter in centimeter. But vernier caliper is used in centimeter only. It is graduated in centimeter. Okay. So it is in the, at the end of the slide, vernier caliper screw gauge will be shown. So their least count is 0.01 centimeter, always in centimeter only, and screw gauge only in millimeter. Okay, comparing these two, which is high precision? Screw gauge. Screw
Vernier
gauge.
caliper.
Screw gauge. That is a screw gauge. Using screw gauge, we can measure up to 1/100 of millimeter, and using using vernier caliper, you can measure up to 1/10 of millimeter. So, which is having more accuracy, more precision means screw gauge only. So, yeah. So, we can use screw gauge instead of vernier caliper. For example, I want to measure the diameter of a small bob, metal bob. You can use vernier caliper as well as screw gauge. But which is more accuracy and more precision means that is screw gauge only. Okay. And then next, random error. This is due to experimental condition like pressure, temperature, voltage, supply, etc. Errors may also occur due to personal errors by the observer who performs the experiment. Random error is also called as chance error because different readings are obtained by a person every time he repeats the experiment. Personal errors will occur. Example, thickness of a wire using screw gauge. We will ask to take large number of readings, that is at least minimum 5 number of readings we have to take, and divide by 5, add all the 5, divided by 5, that is the mean value. So by taking the average more number of readings, you can rectify some error, that is a random error. Next, gross error. The error caused due to sheer carelessness of an observer is called a gross error. 1 minute. For example, reading an instrument without setting properly. Taking observation in a wrong manner without bothering the sources of error and the precautions. இது நான் மறைச்சிக்குமே இல்லை இங்கே இருந்தால் தெரியுது இல்லைங்களா பாருங்க இங்கே இதுக்குள்ளே இருந்தால் தெரியுதுங்களா இது மாதிரியும் அவங்க sir. Then, taking observation in a wrong manner without bothering about the sources of errors and the precautions. Recording. மறைக்குதுங்களா Recording wrong observations. Using wrong values of observation in calculations. So, these errors can be minimized when an observer is careful and mentally alert. He should be alert. Absolute error. That is, difference between the true value and the measured value of a quantity is called absolute errors. 1 minute. Example, AM equal to A1 plus A2. Suppose you are taking 10 number of reading. Then A1 plus A2 plus A3 plus up to A10 by 10. Or AM equal to 1 by 10 into summation I equal to 1 to 10 AI. And mean observed error is the arithmetic mean of magnitude of observed errors. That is delta A equal to delta A bar equal to delta A1 plus delta A2 plus delta A3, like that. Its summation is like this. Relative error or fractional error. Relative error is nothing but mean observed error by mean value. That is a delta A by AM, and percentage error into 100. Combination errors. For x equal to A plus or minus B, error will be del x equal to plus or minus delta A plus delta B. For x equal to A into B, that is multiplication, delta x by x equal to plus or minus delta A by A plus delta B by B. For x equal to A by B, delta x by x equal to plus or minus delta A by A plus delta B by A. Whether multiplication or division, same formula. In power, for x equal to A power n, B power n divided by C power P, then delta x by x equal to plus or minus n into delta A by A plus m into delta B by B plus P into delta C by C. Measuring instruments, vernier caliper, screw gauge, spectrometer. This is a vernier caliper. C is in centimeter. I said no, vernier caliper is always graduated in centimeter. Vernier caliper image is visible, no students? Image of vernier caliper. Come on, Madhi, Virat, Sivakavya.
Sir?
Vernier caliper is visible or not? Image.
Yes, sir.
Okay. What about Madhi, Virat? Madhi, Virat, vernier caliper therudapa? Image?
Yes, sir.
Okay. Then, how to find the least count of vernier caliper? N division of vernier scale division equal to n minus 1 division of main scale division. Then, 1 VSD equal to n minus 1 divided by n of MSD. Least count equal to 1 MSD minus 1 VSD, and least count of vernier caliper is 0.01 centimeter. See, it's graduated in centimeter. Top will be in inch. It will be in inch or centimeter, and mostly we will use centimeter. Down scale is centimeter. Top scale is inch. And there is just one problem. 10 division of vernier scale matches with 9 division of main scale in vernier caliper. If value of 1 division on main scale is 0.1 centimeter, then its least count is dash. That is, we studied n times of VSD equal to n minus 1 of MSD. So n is 10. 10 VSD equal to 10 minus 1, 9 MSD. And 10 VSD equal to 9 MSD, 1 VSD equal to means 9 by 10. 9 by 10 MSD. And least count equal to formula 1 MSD minus 1 VSD. And value of 1 MSD is given 0.1 centimeter here. And substitute first here 1 minus 9 by 10 MSD, that is 1 minus 9 means 1 by 10. Okay, cross multiplying this 10, 10 minus 9 will come, 10 minus 9 by 10, that is 10 minus 9 is 1, 1 by 10 into 0.1, and MSD value is 0.1 centimeter given. MSD is 0.1 centimeter, so 1 by 10 into MSD is 0.1 equal to 0.01. So least count equal to 0.01 centimeter. Screw gauge. This is a diagram for image for screw gauge. Least count equal to pitch by number of divisions on 8th scale. And least count equal to 0.01 millimeter. Spectrometer. N division of VSD equal to n minus 1, and least count of spectrometer is 1 by 60 degree equal to 1 minute. Next one. Okay, this we discussed yesterday class. How many microns are contained in 1 millimeter?
Sir,
Yes,
option B, 10 power 3.
3, 10 power 3. What's the formula I said? That is what's the relation between microns and millimeter? 1 micron equal to
10 power minus 6.
10 power minus 6 meter.
1 millimeter is equal to 10 power minus 3 meter.
10 power minus 3 meter. Then you want to find how many microns are contained in 1 millimeter. So
10 power minus 3 by 10 power minus is equal to 10 power minus 3 to 10 power minus is equal to 10 power 3.
10 power minus 3 by 10 power minus 6. That is 1 millimeter by 1
By 1
micrometer
micrometer.
equal to these things. And 10 power minus 6 comes up, 10 power plus 6, so 10 power 3. So
Yes,
1
sir.
millimeter contains 10 power 3 micrometer.
Micrometer.
That is option C.
Yes, sir.
1 astronomical unit is equal to
1 astronomical unit is equal to
distance between the center of the earth and sun. Value also you may know. What's the value of 1 astronomical unit? Equal to
1 astronomical unit is equal to 3.26 light year.
No, that is parsec.
Okay, sir.
Parsec only 3.26 light year. 1 parsec equal to 3.26 light year. Distance between center of earth and this will be 1.5 into 10 power 11 meter or 150 million meter. Okay.
Okay, sir.
Okay. Which of the following is not a unit of length? Fermi, Armstrong, parsec, shake.
Unit of length.
Not a unit of length.
Not a unit of length. Shake.
Shake is correct. Okay. Now there is one question today. Shake is not a unit of length. Then shake is what unit? Unit of that you try to find out. Okay. Shake is the correct answer. Then
Yes, sir.
shake is not a unit of length. Then shake is a unit of what? Which physical quantity? That is the question. Then which of the following is a large? Tell me.
Sir, wait a minute. Shake is India படிச்சேன்.
இப்பதான் சொன்னது அதான் படிச்ச மாதிரி இருக்கு. Okay, try to find tomorrow. Okay, no problem. Which of the following is the largest unit of length distance?
Shake is the time.
Yes. Where it is used? எங்க யூஸ் பண்றாங்க? Okay. Okay, no problem. Tomorrow you say. Okay, take your own time, not more time.
Okay, sir.
Then, which of the following is the largest unit of length or distance?
The largest unit of parsec.
Parsec, the 1 parsec equal to 3.26 light year. Yesterday we discussed that. This is equal to yes, C option, yes. 3.26 correct. 3.26 light year. Light year equal to how much? 1 light year equal to
1 light year is equal to 1.496 into 10 power 11 meter.
அது வந்து astronomical unit.
1.5. 1 light year is equal to 1 light year.
See, astronomical unit 1.496 Light
1
year?
light year is equal to 9.416 into 10 power 15 meters.
I showed and you are reading. Is it so?
Yes, sir.
No, very good. 1 parsec equal to 3.26 light year. In terms of meter means 3.08 into 10 power 16 meter. Okay. Right. So parsec is the correct answer. Next. A laser beam is used for measuring long distance because beam is very intense, monochromatic, unidirectional, having all these characteristics. Which is correct?
Having all these characters.
Yes. Not only these characteristics, one more extra characteristic is there. It is coherent.
Yes, sir.
High degree of coherence. That also you should include. Okay. Having all these characters. Which is the correct unit for measuring nuclear radii? Angstrom, micron, Fermi, millimeter.
Fermi.
Yes, Fermi is correct. 1 Fermi equal to how much?
1 Fermi is equal to 1 Fermi 10 power something like that.
10 power minus 15 meter.
At 15 meters.
Yes, 10 power minus 15 meter. Angstrom? 10 power?
Angstrom, 10 power minus 10
That's
micron.
10 meters.
Yes, minus 10 meter. Micron?
10 power minus 6 meter.
Minus 6 meter. Okay. Millimeter?
10 power minus 3.
Minus 3 meter. Okay. So answer you said is Fermi. Let's check. Yes, Fermi is the correct answer.
So,
Next. The atomic and nuclear masses are measured in dash. What happened? AMU, carat, kilogram, none of these.
Atomic and nuclear masses are measured. Atomic and nuclear mass. Atomic mass unit apna 1/12 of the isotope of the carbon atom. Carat in the diamond must kg another. None of these.
AMU. Atomic mass unit is used in atomic and nuclear physics. AMU is the correct answer. Okay. That is called atomic mass unit, also called as 1U, unified mass. Okay. Next, 14.57 kilogram makeup dash.
14.57
kilogram.
makeup dash.
One ton equal to 1000 kilogram, 10 power 3 kilogram. 1 quintal, 10 power 2, that is 100 kilogram. One slug only 14.57 kilogram. Okay.
Answer.
Answer is C. Okay. How many quintals?
One
Equal to 1 slug. Another question, slug is where we are using slug. Slug is a unit of one type of unit of mass where we are applying. That is another question, today's question.
okay, sir.
Next question. How many quintals are there in 1 metric ton? 1, 10, 100.
Quintals equal to 10 power 2
How many
kg.
quintals are there in 1 metric ton?
How many quintals are there in 1 metric ton?
1 ton equal to 10 power 3, 1 quintal 10 power 2. Ten quintal equal to 1 metric ton. Okay.
Okay, sir.
1 light year is
9.46 into 10
Yes.
power 15 meter.
10 power 15 meter. 3.084 10 power 16 meter is parsec. 1.5 into 10 power 11 meter is astronomical unit. Okay, approximately 1.5. 1.49 something like that will come. That is 1.5 into 10 power 11 meter. Okay. Answer D. Length cannot be measured by dash. Fermi, dBi, micron, light year.
dBi.
dBi. Then what is dBi? dBi is a unit of what? That is another question. Okay.
dBi.
dBi slug, and one more, what is another question I asked today? dBi slug, and then
Dipole moment of molecule.
yes. What is the inbuilt clock in every human beings? Eyes, ears, human brain, none of this.
Inbuilt eyes.
No, human brain. Inbuilt clock. That is, somebody will say.
So what is the meaning of inbuilt clock?
That only I am explaining now. What is the inbuilt clock means? Somebody will say, that is, if you think that tomorrow you have to wake up at 3 p.m. or 4 p.m. sorry, 3 a.m. or 4 a.m. On thinking same thing, and if you sleep means automatically without any alarm you will wake up. Okay, நீங்க எழுந்துப்பீங்க.
Okay, sir.
So that is our brain acts as an inbuilt clock. Okay,
Okay, sir.
it sets the alarm time correctly. That is based on our thinking. So that is an inbuilt clock. Okay,
Okay, sir.
human brain. Chandrasekhar limit is a unit of dash. Length, mass, time, none of this.
Chandrasekhar unit.
Limit. Chandrasekhar limit is unit of dash.
Star.
Yes, correct. Chandrasekhar is a person related with life stages of the star.
So none of this.
No, mass. Actually, Chandrasekhar limit is mass of the sun. There's a compare with the solar mass. Star whose solar mass is 1.3 times of the solar mass, and less than 1.3 times of solar mass goes as a white dwarf, and greater than 1.3 times of solar mass goes as a supernova expression, and then goes as a neutron star or black hole. So that was given by Chandrasekhar, Professor Chandrasekhar. So that is called Chandrasekhar limit. That indicates mass of the stars. Okay.
Mass.
The instrument to measure time is barometer, chronometer, radiometer, none of these.
Instrumental. Instrument.
Chronometer. Chronology means time order, time. Okay.
Chronology also.
Chronological order, that is, suppose different periods, Mughal period, Ashoka period, like
Okay,
that
sir.
means that will be, you want to fill it in, arrange in chronological order means as per the time order. So chronology means time. Which of the following is not the unit of time? Microsecond, leap year, lunar month, parallactic second.
Which of the following is not the unit of time? Parallactic second. Lunar month.
Lunar month is the month taken as per the moon rotation, moon revolution, that is lunar month. Month, year, second, all the things. Microsecond means 10 power minus 6 second. Okay, 10 power
Parallactic second
minus
into the
6
second.
second. Leap year is 365 plus 1 days, 366 days.
Day.
Lunar month 28 days. Parallactic second is nothing but parsec. What is parsec?
Parsec 3.26 into 10 3.2 is light year.
Light year. What is light year?
Light year is equal to 9.46
No,
10
what
power
is light year?
15
What is
meters.
it? Not the what is the value of
Light
light year?
travel in a vacuum. Light travel in a vacuum for 1 year.
Okay, say the value for light year.
9.6, 9.46 into 10 power 15 meter.
Meter. Then is the unit of meter. Meter is the unit of
Meter.
length.
அப்போ paralytic meter
Yes.
வந்து time கிடையாது. Paralytic second.
For that only I asked repeatedly.
Okay,
So
sir.
option D is the correct answer. Okay. Clear.
Okay, sir.
Next. Time is what a clock reads. Who made these remarks?
Time is what the clock read. Who made this mark?
Yesterday in time.
Sir, Isaac Newton.
Yes. Yesterday in time, related with time explanation, I showed no. That is
Yes,
Sir
sir.
Isaac Newton, Albert Einstein. Two persons said two things. And what's the correct answer?
Sir?
Correct
Sir,
answer.
Isaac Newton.
No. Albert Einstein.
Albert Einstein.
Among the following forces of nature, which is the strongest force?
Nuclear force.
Yes. Strong nuclear force. Among the fundamental force of nature, which is the weakest force?
Gravitational force.
Yes, gravitational force. Okay. Let's move to next chapter. Chapter 3, motion in a straight line. Okay. Mechanics. What is mechanics? Mechanics is a branch of physics which deals with the study of motion of physical bodies. Mechanics can be broadly classified into following branches: statics, kinematics, dynamics. Statics. Statics is a branch of mechanics which deals with the study of physical bodies at rest. That is called statics. It is a branch of mechanics, a branch of physics dealing about the bodies at rest. Kinematics. It is a branch which deals with the physical bodies without taking into motion of the physical bodies, without taking into account the factors which causes motion. That is, due to motion, force will be acting, and because of force only motion which takes place. So due to motion, forces, energy, like that, without considering that is kinematics. Dynamics, by considering the actual cause of motion, that is dynamics. Rest and motion are relative. Rest is an object is said to be at rest if it does not change its position with respect to the surroundings. Whiteboard in the classroom is at rest with respect to the classroom. Motion. An object is said to be in motion if it changes its position with respect to the surrounding. When we talk, run or ride a bike, we are in motion with respect to the ground. Rest and motion depends upon the observer. Object is one situation, may be rest, may be, and other situation may be in motion. This you may observe in the car. Driver of a moving car is in motion with respect to an observer standing on the ground. Groundல இருக்கிறவரை பார்க்கும்போது நம்ம the driver of a moving car is in motion, and for a same driver there is a man who is sitting in front of the passenger seat. For him, driver is at rest. So it depends upon the person who is at rest or in motion. Position. Position of an object is always defined with respect to some reference point. To define the change in position, we have two physical quantities. Noise வருது அந்த பக்கம் மியூட் பண்ணிங்க, பேசும்போது மட்டும் அன்மியூட் பண்ணுங்க. Distance. Distance is the actual path traversed by the body during the course of motion. SI unit of distance, meter. Dimension, L, just L. M power 0, T power 0, just L. Displacement is the difference between final and initial position of the object. SI unit meter, dimension formula same L. Difference between distance and displacement. Distance is the actual path traversed by the object during the course of motion. Displacement is the difference between final and initial position of the object. SI unit meter, dimension formula same L. Difference between distance and displacement. Distance is the actual path traversed by the object during the course of motion. Displacement is the difference between final and initial position of the object during the course of motion. Displacement is the difference Displacement is the difference between the initial and final position, that is delta x equal to x2 minus x1. Distance is a scalar quantity, displacement vector quantity. What are scalar quantity? What are vector quantities? What are scalar? What are vector?
Scalar quantity
Ah,
is represent. Scalar quantity has
yes.
only magnitude, do not have direction.
Yes.
Vector quantity have both direction and magnitude.
Yes, correct. Scalar quantity having only magnitude, no direction. Vector quantity both magnitude and direction. And distance travelled by an object during the course of motion is never negative or zero and is always positive for distance. For distance, when it is in motion, this value never be negative or positive or zero. It's always positive. But displacement can be in zero, positive as well as negative. Distance travelled is either equal or greater than displacement and never less than magnitude of displacement. But displacement is less than or equal to the distance travelled. Distance depends upon the path travelled and displacement, magnitude of displacement is independent of path taken. It only depends upon final and initial position only, that is displacement. Scalar quantity, just now only we discussed, which has only magnitude, no direction. Example, length, mass, time, distance, speed, work, temperature, etc. Vector quantity, which has both magnitude and as well as direction. Example, displacement, velocity, acceleration, force, momentum, torque, etc. Speed, rate of change of distance, that is called speed. Formula, V equal to d by t, unit meter per second, dimension L t power minus 1. Average speed is nothing but total distance by total time. Uniform speed, if an object covers equal distances in equal intervals of time, that is uniform speed. Instantaneous speed, speed of a body at a given instant of time, that is instantaneous speed. Formula, V equal to ds by dt. Velocity, rate of change of displacement is velocity, V equal to s by t. Unit meter per second and dimension formula L t power minus 1, same as speed. Average velocity, V average equal to total displacement by total time. Uniform velocity, if an object covers equal distances in equal intervals of time, that is called uniform velocity. Non-uniform velocity, if an object cover unequal distance in equal intervals of time, or if an object covers unequal displacement in equal intervals of time or equal displacement in unequal intervals of time, that is called uniform velocity. Acceleration, rate of change of velocity is called acceleration, A equal to V by T. Unit is meter per second square, dimension L t power minus 2. If velocity increases, acceleration is positive. If velocity decreases, acceleration is negative, as negative acceleration or retardation or deceleration. Uniform acceleration, if the velocity of a body changes by equal amount in equal intervals of time, that is called uniform acceleration. And if velocity of body changes unequal amount in equal interval of time or equal amount in unequal interval of time, that is called non-uniform acceleration. Okay, this is the displacement versus time graph. Usually time will be taken along x-axis and displacement or distance along y-axis. Okay, and nature of a slope, slope will be positive value and magnitude of slope is constant. What is slope actually? Slope formula, slope is nothing but tan theta equal to, as per this,
Y by X, modulus of Y by X.
there y by x, here as per this in y-axis x and in x-axis t. So
T.
x by t.
T, X by T.
X by t or dx by dt. Dx by dt is the correct way. Okay.
Okay.
That is tan theta equal to, this difference is dx and this difference is dt. Therefore, tan theta equal to dx by dt. And nature of slope is positive, magnitude of slope is constant. And if distance is constant, sorry, if velocity is constant, and one more thing, the slope of this distance time graph give velocity or speed. Note down this. Slope of the distance time or displacement time graph will give velocity. And come here, this is a conversion of displacement time graph to velocity time graph. And here, how is that? If velocity is constant, then it will be goes as a parallel like this. This also straight line, this also straight line. But here, this is slanting, this is a parallel, horizontal line. And here constant. Therefore, slope is 0 and magnitude of slope is constant. Then, if there is no change in velocity, acceleration is 0. Velocity is constant here and acceleration is 0. And here this is a reverse way. Nature of slope is negative, magnitude of slope is constant. Then nature of slope will be negative side. Suppose this is 5 meter per second. Here may be minus 5 meter per second, negative value. Okay. Here may be 5 plus 5. And whatever positive or negative, if velocity is constant, acceleration is always 0. Next. There are 4 equations of motions that are usually used. And these equations of motions are valid only for uniformly accelerated motion. Okay. First equation of motion, v equal to u plus at. Second equation of motion, s equal to ut plus half at square. Third equation of motion, v square equal to u square plus 2as. And fourth equation of motion, Sn equal to u plus a by 2 into 2n minus 1. What is u? U is the initial velocity. V is the final velocity. A, acceleration, uniform acceleration. T, time. S, displacement. Sn, displacement in nth second. Okay. Sn is a displacement in nth second. Displacement in nth second. That is only Sn. And this equation is not valued for non-uniform acceleration. Okay. This is some of the problems that we will see afterwards. Now we will start next chapter. Problems will go afterwards. Okay. Motion in a plane. Chapter 4, motion in a plane. In next class we will discuss problems, just like units of measurement we discussed, no, like that. Motion in a plane, scalar and vector. What are scalar? Quantity which has only magnitude, no direction, are called scalar. Example, length, mass, time, work, temperature, etc. And vector is a quantity which has both magnitude and direction. Apart from that, there is one more quantity, tensor. Tensor means physical quantity which has different value in different direction, are called tensor. Example, pressure, stress, elasticity modulus, moment of inertia, S per refractive index, these are all tensor. Representation of vector. Vector is represented by a straight line like this. It carries an arrow head at one extremity. One side it will be arrow, and arrow side will be called as head and other side will be tail. And the length of the line represents the magnitude of the vector, and tail is a point from which the vector originates. Head is a point at which the vector ends. Addition of vectors. You are following now, students?
Yes, sir.
Okay. Addition of vectors. Vector addition is commutative. That is, a plus b equal to b plus a. That is, by change the arrangement as a plus b or b plus a, it will be same. Vector addition is associative. It means a plus b plus c, that order, b plus c plus a or c plus a plus b, it will be same. Vector addition is distributive. That is, m into a plus b or ma plus mb, both are same. And maximum value of vector addition is a plus b. Minimum value of vector addition a minus b. direction of cosine. That is cos alpha equal to ax by a, cos beta ay by b, cos gamma az by a. Here ax, ay, az are the components of vector, and sum of the cosine square of each angle is equal to unity. Is a law of direction of cosine. That is cos square alpha plus cos square beta plus cos square gamma equal to 1. It is called law of direction of cosine. Unit vector. Unit vector means vector of unit magnitude and the same direction of the unit vector, given vector. Example, a cap equal to a vector by modulus a or magnitude a. That is a cap equal to a vector by modulus of a. It should not be written like this. Wait. How it will be written means a cap equal to a vector by a modulus. Okay. And unit vector is unitless and dimensionless vector and represents direction only. Symbol ijk represents unit vector along x, y and z direction. Null vector. Null vector is a vector which has zero magnitude and arbitrary direction. It is represented by 0 and is also known as zero vector. And velocity of stationary object, acceleration of an object moving with uniform velocity, result of two vectors in opposite direction are example of null vector. Equal vectors. Two vectors are said to be equal if they have equal magnitude and same direction. Negative vector, that is, if one of the vector acting in opposite direction, we can represent that as minus a. That is only negative vector. Multiplication. Multiplication of vector a multiplied by a real number means n into a vector. And suppose multiplication of vector by a scalar, then s into a, and a is multiplied by a scalar s and it becomes a vector sa vector whose magnitude is s times of the magnitude of a and it acts along the direction of a. Example for this is f equal to ma. F equal to m into a. A is the acceleration, f is a force, both are vector quantity and m is a scalar quantity. Then for addition of two vector, we will follow different methods. One is triangle law. And the basic thing is, that is, suppose you want to add AB plus BC equal to AC. AB here and here this is the head of the AB and its tail should be touched by second vector BC. Then resultant vector will be closing sides of the third sides of the triangle, that is AC. That is only AB plus BC equal to AC. Same way triangle law. Same, this triangle also we can say this one as, suppose two vector acts as a two adjacent side or two sides of the triangle. Then third side of the triangle in the reverse order, that is only triangle law of vectors. Same way parallelogram law of vectors. If two vectors A and B acts as a two adjacent sides of the parallelogram, then diagonal joining these two vector, that only acts as a resultant vector R. Its magnitude is square root of a square plus b square plus 2ab cos theta, and tan beta equal to b sin theta by a plus b cos theta. Polygon law. If number of vectors are there, here is one vector a vector, and here is one vector b vector, here one c vector, here one d vector, here e vector, here f vector. Then you want to find the resultant means, then closing sides of the polygon in a reverse order. This is only a resultant vector R. Okay. Next, subtraction of vectors. Subtraction of vector b from vector a is defined as the addition of vector minus b to a. That is, a minus b means a plus minus b. Minus indicate it is acting in opposite direction. Rectangular component. That is, a vector is resolved into two or three components, that is ax, ay like that. That only we are calling rectangular component. A equal to ax plus ay, and A, that is equal to A1i plus A2j. What is A? A is A cos theta, that is horizontal component, and AY equal to A sin theta, that is vertical component. Polygon law, just only we discussed, that is number of vector in a particular time is represented magnitude and direction, then its resultant vector is comes by taken in opposite order as per the polygon law. And subtraction of vector, A minus B equal to A plus of minus B. Oh, it's repeated, so it's repeated. Rectangular components only we discussed. Ax equal to A cos rectangular component. Suppose two vector acts as a, which makes certain angle theta angle like this, theta angle. Then this A vector resolved into two component as Ax or A cos theta, and here is Ay or A sin theta. Okay. Dot product of two vector. Suppose two vectors are multiplied by scalar product or dot product, that is A dot B, means it's a scalar product or dot vector. Here its resultant will be not a vector, it is a scalar. Example, W equal to F dot S. Both F and S are vector quantity, but W work or energy is not a vector quantity, it is a scalar quantity. And A dot A equal to A square or A equal to A dot A power 1 by 2, and I dot I and J dot J, K dot K equal to 1. Other thing, I dot J or J dot K, K dot I equal to 0. Dot product there, A dot B equal to AX BX plus AY BY plus AZ BZ, that is equal to A dot B equal to B dot A. Cross product. Cross product is just like dot product. Cross product is nothing but, yes, A cross B equal to C or AB sin theta, and resultant also vector quantity. Geometric interpretation, that is that is a magnitude of vector product of two vector or cross product of two vector is equal to area of parallelogram whose sides are represented by two vector, or twice the area of triangle whose sides are represented by two vectors. Properties of cross product, that is A cross A or I cross I, J cross J, K cross K 0, I cross J K, J cross K I, K cross I J. If you taken as reverse, as J cross I means, J cross I means minus K, J cross K, K cross J means minus I, then I cross K equal to minus J. And A cross B, how we will find means by just like matrix method, I J K, AX, AY, AZ, BX by Y, BZ. Direction of vector product. Suppose C equal to A cross B, then C value will be perpendicular to A and B. Okay. C is perpendicular to A and B, and the value of C, direction of C can be found by two rule. One is right hand screw rule, another one right hand thumb rule. Both will represent that A and B in one direction and C must be perpendicular to A and B. That is only both the rules will be explained. Relative velocity. Relative velocity is the velocity of one body with respect to another body. And if two bodies A and B are in opposite direction, velocity will be increased as R equal to U plus V. And two velocity acting in same direction, that velocity will be decreasing, U minus V. Then angle between the two is tan theta equal to U by V. It will be used in rain. In rain problem and all, we will use this one. Projectile motion. What is projectile motion? Anything thrown in space and then allowed to fall under the influence of gravity is called projectile. And path of the projectile or trajectory of projectile is parabola. This only. See, this is a projectile. And projectile is two type. One is horizontal projectile and this is oblique or angular projectile. Horizontal projectile means at certain height. If you throw the object at certain height and it falls only under the influence of gravity, that is called horizontal projectile. Formula, time of flight, some of the formula we want to learn. Time of flight, note down the formula. T equal to square root of 2h by g. H is the height, t is the time of flight. Time taken for the object to remains in the air from the thrown to hit the ground. And r equal to u into 2h by g. Range r is the horizontal range, distance between the point of projection and where it's the ground. That horizontal distance only range. And resultant velocity v equal to vx square plus vy square, v equal to u square plus g square t square. And for oblique projection, this is the formula. Maximum height h max equal to u square sine square theta by 2g. Time of flight 2u sine theta by g. Horizontal range u square sine 2 theta by g. Maximum horizontal range theta equal to pi by 4 or max equal to u square by g. Circular motion, that is angular displacement. That is just like theta is a angular displacement. And angle is a position vector sweeps out in a given interval of time. That is called circular motion. SI unit of angular displacement is radian. It is a dimensionless quantity. And angular velocity denoted by a symbol omega is equal to rate of change of angular displacement as del theta by del t. Instantaneous angular velocity means limit del t tends to 0, del theta by del t equal to d theta by dt equal to omega. And relation between linear velocity and angular velocity v equal to r omega. Time period. Time taken to complete one revolution is called time period. It is denoted by t. Angular acceleration. Angular acceleration alpha is nothing but rate of change of angular velocity. Relation between linear acceleration and angular acceleration a equal to r alpha. And frequency nu is the number of revolutions per second. It is also called as reciprocal of time period. Its unit is hertz. Okay. Uniform circular motion, non-uniform circular motion. In uniform circular motion, centripetal force F will be there. Non-uniform circular motion, two forces. One is centripetal acceleration Fc, another one tangential acceleration F square equal to Fc square plus Ft square. And centripetal acceleration formula AC equal to V square by R. And centripetal force formula F equal to mv square by R. Vector notation mv square by R into R cap. And this is a formula for skidding mv square by R equal to Fs, and the condition for skidding. For safe tone, not skidding means if mv square by R is less than or equal to mu s mg, safe one, and if mv square by R is greater than mu s mg, it is skidding. And what is mu s? Mu s is the coefficient of static friction. Coefficient of static friction. Backing of tracks. That is in turning and all, that is outer edge will be raised slightly. That is called backing of tracks, and a frictional force is provided for mv square by R. And here the tan theta is the angle equal to v square by rg. Outer edge of the road is slightly raised to avoid skidding. Suppose if it is not raised, then skidding will occur. Formula velocity v equal to square root of rg into tan theta. V is the velocity, r is the radius of this curve path, and g acceleration due to gravity, theta is the angle. Okay, so this chapter over. So next chapter will be, so this problem we will do in some other class. Problems are there. So next class we will start chapter 5, laws of motion. Okay. Okay, students. So in some other class we will do problems. As for 2 to 3 units we will do problems. Okay. Some selective problems we will do. That will be useful for our NEET exam. Okay. Okay, students. Any doubts?
No, sir.
Okay. Okay. Thank you. Thank you, students. Thank you all.